Okay, hello everyone. So we are from Group 6 from the Soil Mechanics Laboratory session. So here we are going to discuss about our mini project. The title that we got is the strength characteristic of subgrade soil. So to understand more about the subgrade soil, let us all share about what we understand about the subgrade soil. So who's gonna start first? If no one's gonna start first, I'm gonna just briefly say what I understand about subgrade soil. So a subgrade soil is type of soil that is used mainly for construction when the soil is subjected to a bearing, a load. So when we say about the subgrade soil, it is a soil that can carry out load and also have a load bearing capacity. So next, who's gonna talk about the subgrade soil?
Yeah, I also found that information because written here is a subgrade is made up of native soil that is being compacted to withstand the load. So it's a layer required in many structure and it needs a certain characteristic for the subgrade soil. And then I also found that the characteristic of the subgrade soil is depends on the type, the moisture content, dry density, and internal structure of the soil. So I think from the characteristic there, we can determine the test needed to make sure we meet the characteristic as I mentioned before. So what do you guys think? What do you guys think about the test needed? What is this required test?
I think for the type of soil, we can use the particle size distribution test. What do you guys think? And for the moisture content, maybe we can carry out the moisture content test. For the dry density, I'm not quite sure. Maybe sand contest or something like that.
Others?
Maybe Atika would like to share about the dry density. Is it true that the sand cone test is, is suitable to be used as a dry density test or not? Or maybe Mahmoud can help about, is it true that the sand cone test is suitable to as a mean or assess the dry density of the soil, whether it's related or not to the strength?
I think yeah, because like if we for the dry density, yeah, we could use that, and for the moisture, we could use the moisture content test. Basically, we oven dry the sample soil we have, then before oven drying it, we measure it, and after oven drying, we measure it again to see the difference in the weight, which will be the water content. That's what I know about it, like to find the water content of the soil.
So far the test that we list out is moisture content, dry density, some more? Dry density.
Particle size distribution test.
Particle size.
Okay. When we look at the definition of the strength, what do you guys understand? Like what tests can we assess the strength of the soil? Okay, maybe we can start with. I think I want to share.
By just now, I think we need to add a compaction test, right? Because it's like we miss it. And another I think is just now we will doing a specific gravity test. So from that we will know whether the sand and the soil will be fine or coarse. So we will determine whether to do constant head permeability test or the falling head permeability test. So I think that's from me. Anything from you guys, or you think that it is not necessary to do this test?
I'm not sure about the specific gravity test because I'm not sure. Milo, I mean Farine.
But looking at the definition of shear strength, so we need to assess it by using the direct shear test, right?
Directional try
What you
dengan
guys think?
triaxial
Yes.
triaxial.
Or maybe, when we talk about the subgrade, do you guys think the compaction or standard rotor compaction test is needed?
Atika mentioned that before. Then the
I thought it's specific gravity or standard. Okay.
before that.
Oh.
Standard.
Okay.
One, two, three, 4, 5, 6. So we have 6 tests so far. Is that okay? Or we need to add more tests or more tests needed?
Okay. I think it's just too much. Don't you guys think
Yeah,
so?
I think too much. Because report only 10 page, right?
Okay, then we have to get rid one or two.
I think we must get rid of 5 and take only 1.
Lose. Okay,
Don't you think?
why don't we get rid the triaxial? I think direct shear box is enough, I think, to determine the strength. Or
Arin, can you state the 6 tests? State it back. First.
First, dry density, contest, and then the particle size distribution, and moisture content, shear direct box test, triaxial, standard compaction test.
All right, thank you.
And then I read about the triaxial compression test. The test is to obtain shear strength and deformation parameter of cohesive soil. So do you think it's fit our topic? Triaxial? I don't know.
I think from what I understand about the direct shear test and also triaxial, it can be triaxial test can be used on every type of soil, but to compare which one is the best between the direct shear test and also triaxial, I think triaxial is the best because okay, from what I understand, the direct shear test it makes the soil to fail within the line that is created by the test itself. But the triaxial, the failure line is created by the soil itself. So it means that when we use the direct shear test, it does not really examine the failure line. I mean, we cannot really examine the strength of the soil due to the failure line itself is created by the test. But the triaxial, the failure line is created by the soil. So it means that the soil itself is the factors that affect the failure line, not the test. You guys understand what I mean? Okay, let me explain. Okay, the direct shear test, we have like two direction, right?
Mm-hmm.
So when we push these two directions together, it will create a line, right?
Yeah.
So the line itself is created by the load, not the soil wants to create that line.
Understood?
Right. Okay. So that's the reason why triaxial is slightly better and then compared to the direct shear test because it examines the failure line of the soil. What do you guys understand?
True, but by the definition of the subgrade itself, it states that it's compact within the load means we need to consider the load also, not only the soil itself. Did you get it? What I'm trying to?
I think you mean the load. We need to know it is for the thickness, like how thick we need the subgrade soil during the construction.
Yeah, that.
So the load is not needed.
Yeah,
Do you get me? Or do you want me to explain more?
Can you explain more?
Okay, so for the characteristics of the subsoil, we don't need to know the load. We only need to know the load during the construction process. So we know how thick the subsoil we need. How thick is it that we need? But for the like just the characteristics of the subsoil, we don't need to know the load.
Okay. Thank you, Mahmood. Thank you, Farah. So we decided to get rid the direct shear box and take triaxial.
Yes.
True.
True kan? Everyone agree or not?
To me, I agree. Uh,
Okay, and then the triaxial, they have two types. Unconsolidated undrained dengan consolidated undrained. So which one? Did we need to do both?
I think we need to know whether our soil, you know that it is a subgrade, right? Subgrade means that it is already compacted. So we need to know whether our soil itself is consolidated, means that whether it's consolidated or not, and also whether it is drained or not, whether it's wet or not. So then we can determine. But okay, actually, when we talk about the drain, undrained, and all that, and those parameters are not needed in our test, right? So I think maybe we should stick to direct shear test.
Okay. Okay.
Oh,
Okay, we just keep IV first, the test needed, and then we refer to doctor after that. Maybe ask for some opinion.
Yes, that's better because
Okay, so
Yeah.
KRB first. Okay, and then anything? Anything more? Anything to add on?
what about the objective?
Okay, the objective. The objective to ensure our subgrade soil fit the characteristic to be subgrade. I was like,
I think is to measure the strength, right?
Yeah.
Just we need to know the strength of the subsoil.
others? I think we need one more or two more about the objective.
To me, I don't know, but we talk about the moisture content. So our objective must related to the strength. So moisture content and strength. So why not our objectives will be the effects of moisture content to examine to study the effects of moisture content towards soil strength.
Mantul. Very good for Ain.
Okay, other
Effect of to strength. Mm. Okay, because we do the standard proto compaction test, which is related to moisture content and dry density, right?
Yes.
Okay, so the relationship between standard proto with dry density and moisture content, anyone remember the relationship?
I think we need to plot the graph for dry density versus the moisture content, right? And relate the two of them.
Yeah. Okay, so the objective for that, so that we can determine the optimum.
Yeah, optimum water
Moisture
content.
content.
Uh,
So what we're going to write for the objective to determine the optimum moisture content. Like that.
I think can work.
we have
Yes.
we have right dry of optimum and wet of optimum right on our previous. So why not we relate it with the compaction because as we all know that the dry optimum and wet of optimum is related to the compaction factor.
Mm-hmm.
So we have like 95% of maximum dry density, 95% of wet dry density. So we use the factor of maximum dry density and relate it with moisture content that we got from the soil so that we can assess the strength of the soil. You get what I mean? Like, for example, from our previous lecture, last plus soil mechanics 1 class. We use the moisture content and assess whether the moisture content exceed 95% or not, like the standard JKR one. You guys remember?
Okay. Okay, so the objective is
to study the relation between moisture content. Yeah. Why we also relate to moisture content? Is it possible? Moisture content and also yeah, the moisture content and the compaction degree. I'm not sure, but that's what I understand.
it's okay. You just write it first and then figure out that later. So I think we have 3 main objectives right now. So anything else?
Atika, do you want to add anything on the objective?
No, I think it's okay now.
Okay. Mahmoud, do you have anything?
I think I'm okay, but I was just reading something that said if we want to know the strength of the subsoil and also what thickness we need during the construction, we could do the California bearing ratio of soil.
So you means we have to add on one more test.
One more, yeah, it's the California bearing ratio, yeah.
We tried to get rid the test and then now we have to add on the test. Okay.
Because you asked about the thickness, so I was just reading and it said like engineers use the CBR to determine the thickness later.
Okay. We can add on that first. So can you repeat the objective to determine?
It's also part of the strength. The strength and the strength and the what's called base course materials of the subgrade soil.
Okay, so to determine the strength based on the thickness of the soil.
No.
No.
The strength and the like base course materials of the soil.
Base course material.
I think I could type it.
Okay, thank you. Okay. So I think from discussion this evening, I think we get briefly about our mini project, and I'm sure we can do our more further research after this. So I think that's it. Or maybe you guys want to add something?
Rin,
Yes,
so our test is 6 Just now,
6 kan?
6. 7 including CBR. But the
I think
traction
we
and
could remove the
direction
CBR then.
KIV first because we're not so sure whether to get rid the shear or the triaxial.
Yeah.
So I think that's it.
So next week we will ask doctor, right?
Yeah.
Maybe Arin can conclude the discussion this evening. the test needed and also our objective. That's all.
Okay. So for the conclusions, for our discussion this evening, we basically have 7 tests, which is CBR, standard compression test, triaxial, direct shear, moisture content, particle size distribution, and dry density. But for the triaxial and direct, we're still on KIV because we're not so sure about that. And then for the objective, so far we have 3 objectives. Main objective, which is we want to know the strength of subgrade soil. And then we need to we want to study the effects of moisture content to the strength. And then the last to study the relation between moisture content and compaction degree. Or other than that, we want to know the strength and base cost material. That one, the last one. Okay, so four objective so far. So that's it for this discussion.
Wait, I think, yeah, I think like maybe because at the third objective,
Okay.
we mentioned about the relation moisture content and compaction degree.
Yes.
Maybe we can check. We can change it to the relationship between the dry density and strength of soil.
Okay.
Because we have the sand kunta sand. So yeah. Okay.
So dry
That's all.
density kan?
Dry density.
And
Because
strength.
the strength.
Okay. Sure.
Relation between dry density and strength of soil, subgrade soil.
Because the standard proto also related to dry density also and moisture content. Okay. So that's it. Thank you everyone.
Can I add something small? Yeah. For the CBR test, I don't think we need it because it says it have the same, like we could get the same thing from the direct shear test.
Okay.
Yeah.
So we get it, okay? The CBR.
Yeah, get it, yeah.
Okay. Anything before I end the meeting? Okay. Thank you everyone.
Bye.